Okay, so we have discussed up to G part. Let us discuss H. So no, we have not discussed Z. So let us discuss Z part. Once again, reactions of Grignard reagent. So Z you have. So please keep copying fast. So G you have 2 PHMgBr. So 2 mole of PHMgBr you have been given. So you have been given PHMgBr. And you have to react with CH3, let us say a COOET. So what will be the product after hydrolysis? You have to write down the product after hydrolysis again. Now see, once again you have a good leaving group here. So you will have two molecules, so two step reactions. So first step nucleophilic acyl substitution and the second step is addition. Let me see how many of you are able to do this one. Pretty easy one, this one. Yeah, so now you know, so you will have pH minus, so pH minus CH3COOET. So this will attack here, this opens up, so you will have pH CO minus CH3 here you will have, OUT here you will have. You're getting now OUT can act as a good leaving group, so this comes back, this goes out, so you will have pH CO CH3. Are you getting? Now next mole of PHMgBr you can use because PHMgBr has been taken in 2 moles. So PHCOCH3, and if you react with pH minus, the next mole of pH minus, this attacks here, this opens up, and if you do hydrolysis, I can write on the final product after hydrolysis. So if you do hydrolysis, O minus will be converted into H plus, so COH, CH3, and one pH group is attached there. So this is the final product you are getting. Are you getting or not? Let us discuss GH. So what is the H? You have in this case this compound. I think all of you have copied this one. So you have this, and here I have a double bond, and now this side you have CH2 COOMe, OUT or OMe, both can act as good leaving group. Now this is reacting with LiAlH4. What will be the product if this reacts with LiAlH4? Now this is simple. In this case you have to take H minus as a nucleophile, and LiLH4 is taken in excess. You have to give me the final product. You can use excess H minus. So what will happen? This H minus will finally, so let us try to understand. One H minus can attack here. This opens up, so this will convert it into alcohol, OH. Next H minus can attack here. This goes up, comes back, and this go this side, so we will convert it to aldehyde. Because this goes acylic substitution, this is replaced by simply a hydrogen, so we will get an aldehyde. But further on aldehyde, this H minus can further attack. So this attacks, finally it will be converted into alcohol. Are you getting or not? So you see, in this case the final product will be, I am writing the final product. You will have one OH here, hydrogen is there. And this side you will have CH2. And this will be finally converted into CH2OH, alcohol, CH2OH. Are you able to understand or not? So one H minus will attack here. So this is easy. O minus, and if you do hydrolysis, the next step, this O minus will be converted into HOH. Now this is, here also you will have H minus that will attack, this opens up, returns back, this leaving group goes, so you will have aldehyde. Now H minus further can attack on aldehyde, aldehyde can be further reduced to alcohol, so finally you will have CH2O minus, that is after hydrolysis you will have OH. So finally this will be the product after hydrolysis. Let us say I. So what is the I part? I think you have copied this one. So many vehicles downstairs, so many noises downstairs. What we can do? So I we have this compound with NaBH4. Now this you have to slightly remember. So I have this and the same compound CH2 COOMe. but this time this is treated with NaBH4. Now what will be the product in this case? You have to give me the answer. Okay, let me help you. This is basically, so LiLH4, if you see the previous one, is acting as a reducing agent. Double bond O has been converted into OH, so you have basically added hydrogen. So this can act as LiLH4 can act as a reducing agent. Similarly, NaBH4 can also act as a reducing agent. From here you can have H minus. But this time this is not so a strong reducing agent. This is a strong reducing agent. This is a weak reducing agent. So what this reducing agent will do, this can attack here. This means this carbonylic group can be reduced. But this ester group cannot be reduced, because now if you see on this carbon there is not so much positive charge. So H minus cannot attack here, because the H minus coming from NHBH4 is not so intensified H minus. You can say this is not so nucleophilic. It's a weak nucleophile. So that's why it can act as a weak reducing agent. This will reduce the carbonylic carbon, but this will not reduce the ester group. So what is the product? So we will have, this is the final product. So this is OH, H, and this will remain as it is because this group is not reduced. CH2, CO, OMe. So this group is not reduced. Are you getting? So NaBH4, so you can write in your copy, NaBH4 can act as a weak reducing agent, while LiLH4 can act as a strong reducing agent. LiLH4 can even reduce ester or acid, but NaBH4 cannot reduce ester and acid. So let us write NaBH4 cannot reduce acid and esters, while LiLH4 can do. Okay, we'll discuss the next problem.